basics of subtracting fractions. So we might have 3.5 minus, subtract or take away 1 and 1/3. And again, I make sure to keep my whole numbers double the size of the fraction represented. So we could do the traditional method, which would be, and this, it's really important to go through this method first. There's nothing wrong with this. And if you like to do things in this way, sometimes we need to process this before we can do the shortcut. That's very, very important because we have to have that understanding behind us. Like, for example, if we want to multiply a number by 10, we understand that by multiplying by 10, we move it one place to the left on the place value chart. But after we have that understanding, we can just take a shortcut by saying anytime we multiply by 10, we just add a 0. But what we're really doing is making a shortcut for what we already understand. So there has to be that understanding there first. So we have 3 times 2, because we know that a whole number in halves is 2 over 2. So we have 3 times 2, which is 6, plus 1, which is 7. So now we have 7 halves. Take away 1 and 1/3. So we have to turn that into an improper top-heavy fraction. So we multiply the denominator because we know 1 whole in this case is 3/3. So we say 1 times 3 is 3 plus the extra numerator here, and then we have 4. But of course we can't do this because our denominators must be the same. Our denominators are for information purposes, especially when we're subtracting. So they need to look alike. Otherwise we're subtracting 2 different values. So what do they have in common? Just like using your times tables, we say, right, 2 and 3 both go into 6 with no remainders. They also go into 12, but we try to find the lowest one to make our lives easy. Always looking for the easy, most logical route. Math wants you to succeed. It's very logical. So we've got 2 times 3 is 6. Okay, and what if I do to the bottom, I do to the top, because again, when you think about giving a present to one little child who's like 3 years old, their friend will be like, what about me? Or their sibling will be like, hey, you forgot me, I want what they have. And the numerator and the denominator, think about them like that. Whatever you do to one, you have to do to the other in this case. So 7 times 2, so that will be, oh my goodness, not 7 times 2, that's a 1. Oh no, it is 7 times 2. What am I doing? 7 times 2, sorry, 7 times 3, we'll get there. 7 times 3 is 21, and 2 times 3 is 6. Now we're going to subtract. We're going to get there. 3 to turn it into a 6 is 3 times 2. If I do to the bottom, I do to the top, and then that's 8. Now you've got an insight into my thought process there. Now it's just straightforward subtraction. What is 21 take away 8? You could say 20 take away 8 and you know it's 12, and then add the extra 1 and you know it's 13. So we have our answer up here, 13 over 6. And as you know, the division sign, it just really is all about fractions, because we could substitute these dots with this number and that number, and you'd be like, oh, so percentages, decimals and fractions, they're all related. They're like cousins. So here we go. We'll say how many 6s go into 13. That will be 2, remainder 1. So we will say 2 with 1, and then what do I do here? I don't have a denominator. Well, you do. You have a 6, which is my divisor, becomes your denominator, and that is your answer. But that takes ages. So once this is embedded, I like to do it this way. So let's try that again. 3.5, take away 1 and 1/3. Okay, looks good. Well, let's isolate these whole numbers, and then we can say, make it so easy. What's 3 take away 1? Well, that's 2. And then we're just left with these 2 fractions. Now, it's important because we need to know something about these fractions. Is 1/2 bigger than 1/3? So let's have a little look. This is 1/2, and then this would be approximately 1/3. Yes, so a half is bigger than a third, and it's important because that means it can be taken away. We can do that without getting into negative values. So now we can go ahead and we can subtract just like we did before. So now we will say 3/6, which definitely is a half, take away 2/6, and I'm getting ahead of myself telling the answer there. So what's 3 take away 2? That would be 1. So then we must not forget, we can put it here, so we must not forget the 2 over here. So we'll say 2, bringing back that whole number, and they have 2 and a 6. Now this is very important because what do we do if, for example, that fraction is reversed and we had 3 and 1/3 minus 1 and 1/2. Now that's going to be easy. 3 take away 1 is 2. But hold on, 1/3 is smaller than 1/2. So now we have our answer. We can take a whole number here, and we must take from it, just like we would do in regrouping with subtraction. This is why we do this first. And then this extra 1 we've taken, we add it to the first question to make it bigger, the first number. So now we have 4/3 take away 1/2. And that's when we can start to turn them into the same denominator. So that would be like saying 8 take away, so 4 times 2 is 8, 1 times 3 is 3, that would leave me 5. We know that new one denominator is 6, and now our answer, bringing back this, because we've used up that 1 here, bringing back that 1, we have 1 and 5, 6. So let's do that again. Let's imagine we have a nice one here. We have 10 and I'll say 10 and a fourth, take away 7 and a half. Now 1/4 or 1/4 is smaller than a half. So let's do this one first. And if you want to, pause the video so that you can do this. The main point of this is you might even be able to work out the answer in your head. It's the process that we're practicing here rather than the actual sum. That's why I'm keeping it simple, because the same process will apply to, the same steps will apply to this simple question as they will do to the more complex ones when we're looking at all kinds of different fractions. So 10 take away 7, let's do that on the side. Okay, that's 3. And now we can go ahead with 1/4 or 1/4 take away 1/2. Oh goodness, that's just not going to work out because the fourth is smaller than a half. So what we do is we go to our whole numbers and we take a whole number and we add it here, and now we're talking. So 1 times 4 is 4, plus 1 is 5, so now we have 5/4. Take away 1/2, and we can turn them all into fourths because 2 will go into 4 with no remainder. Whatever I do to the bottom, I do to the top. Excuse my pen here, I don't know what's doing. So we've got 1 times 2 is 2. Take it away. 5 take away 2 is 3. 3/4, and then we've got the 2 here, because we gave the 1 over here. And we've got 2 and 3/4. You could do it the other way, which would be, for example, 2 times this, like here. So we'd have 10 times 4 is 40, so that would be 41/4. Take away 7 times 2 is 14, and that would be, looking up here, which would be 7 2s are 14, that would be 15 over 2, so that would be 41/4, and then we would times that by 2, take away 30, and that would be 30/4, so that would leave us with 11, okay, over 4. And as we work that out, how many 4s go into 11? That would be 2, and then how many left over? That would be 3. And then we would have here, just trying to squeeze in here, 2 3/4, exactly the same working out. Now, by doing that, it might be easier for you, but this is a nice shortcut. And maths is all about finding alternative strategies. So let's go to the next one. I've got a blank page here, and I'm going to give you a question to try. And I want you to practice as well, making your whole numbers double the size of your fractions. So we could have 12, and let's make it nice. Let's say something like 12 and 1/7. Okay, take away, we'll say 4 and 3, I would say 3/4. So, or 3/4. See how you get on there, because you can tell that 3/4 is much bigger than 1/7. How would you go about that? What you can do as well is you can draw this on an iPad. You can record yourself writing on a whiteboard. You can send a video where you talk through what you did, or you can just show me you're working out. All of it, I love to see. Thank you so much.